Welcome to Module 6, that on tsunamis. Let's go through those learning objectives together. After completing this lesson, students will be able to define the term tsunami, recognize how tsunamis are generated, how they propagate at sea, and then how they inundate shorelines. We're going to list the 6 causes of tsunamis, compare and contrast the characteristics of tsunami waves as compared to surface waves, and we'll also list the conditions that must be present for an earthquake to cause a tsunami. In addition, we'll recognize the characteristics of a tsunami involving speed, scale, and wavelength. We'll identify hazard zones in the Pacific where tsunamis may be generated. We'll also list the natural warning signs that the tsunami may be about to occur. And we also want you to be able to identify the major health consequences of tsunamis. We'll also identify measures that lessen the health impact of tsunami disasters. So what is a tsunami? A tsunami is a series of waves that are generated by a sudden, large displacement of seawater. So let's talk more about tsunami genesis and propagation, because it's really important to understand where these things begin, how they occur, and so on. So remember back to the earthquake module that we just finished as well. We talked about this idea of the tsunami being generated by an earthquake. And so really what happens is we have these tectonic plates cover the surface of the earth, and where they meet is where earthquakes occur, right? And tsunamis actually start in these areas that are called subduction zones, meaning that one area of the plate goes under the other. And the pressure is building over a period of time. Movements relatively slow, but after a while something slips. And when it does, part of the one plate actually pops up. And that area, that displacement of land, then translates into the ocean above itself. And that goes all the way to the surface of the entire ocean itself, so maybe many hundred feet. And then that actually propagates just the same as if we were to drop a pebble into a pool of water. You know, if you take a pebble and you drop it into water, you can see wave, and not only just one wave that branches out, but you'll see subsequent waves, successive waves that come out from simply one pebble. We have the same phenomenon in a tsunami, only it's happening at the bottom of the ocean itself. But the most significant aspect about this is it's not just affecting the top surface or the bottom of the water itself, it travels through the entire column of water. And so you have water from all the way at the bottom of the ocean to all the way at the top surface of that ocean, where that water is being moved, and it's being moved outward and travels throughout the ocean. Now that's fine if it doesn't hit any land, but when it does hit land, that tsunami then climbs up the surface of the land and pushes this wave, not just the surface as we would normally see surface waves, but actually pushes that entire column of water. So for example, we may have land that comes down like this and a harbor, and the column of water then climbs up this area and then propagates and then inundates into the land itself. So we have this phenomenon of the way that water acts. Now we know from physics, and those of you that may have suffered through a physics class from time to time, if you're like me, I find it painful. Other folks love physics. But one of the things I learned in physics is that water actually transmits power, it transmits pressure relatively well in comparison to other type of media. And so if you have a certain amount of pressure that goes through water, it can travel through a long distance of water without ever losing much energy. And that's what happens in these tsunamis. They travel very quickly, and they also go extremely long distances because of the phenomenon, the characteristics of water itself. And so when this travels up like this, you have a lot of force going on and the ability to go a long distance. In addition as well, when it comes up into the land like that, the tsunami, the water column itself actually starts to climb and then falls in on itself. And when it does, it tends to move up even further into the land. So that's the idea behind tsunami genesis, which is the generation or the origination of the tsunami itself. The propagation is as it goes through the ocean. And then inundation phase is when it actually comes up and inundates the land itself. And I want to compare now surface waves to tsunami waves, because sometimes people think in terms of these as well. You know, we kind of expect to see a tsunami with that big capping wave, that big rolling wave that we would see, for example, in the people surfing, with the curl and everything. But actually, tsunamis aren't like that. Surface waves are actually a circular phenomenon that occur only on the surface, and they're usually driven by wind. And so you see this rolling of the surface itself, but down deep in the water, underneath that surface, there's not much movement of the water itself. Whereas in tsunamis, the entire column of water, from the very surface all the way down to the ocean floor, all of that water is moving, and it's moving all together. So rather than a surface wave that rolls over in cups and you have wave after wave, what you see in a tsunami is a large column of water that actually just looks like the water is rising. If you see it the first time, it looks like the water rises up and then comes in. So we don't see this rather dramatic effect. And of course, it can be more dramatic if the water gets to 50, 60 feet, 70, 80 feet in some cases. But what we really see is this entire structure of water moving rather than the surface waves themselves. And so it's a little different than we would normally see with other types of surface waves. So where does the word tsunami come from? Well, you know, the origin of this word actually tells us a lot about how tsunamis act and where we can go to protect ourselves as well. Tsunami is actually a Japanese word, and it means harbor wave. And the top character of su and the second character being a nami, or harbor wave. And the reason why it's called harbor wave is the Japanese noticed when the tsunamis would occur in their country that the harbors were most affected. Why is that? Well, you can imagine as that column of water is coming up into a harbor. The harbor has a nice sloping floor of the harbor itself, and that tsunami can then climb that harbor very easily. Now let's compare that, for example, to some place that isn't a harbor where it's a cliff that meets the sea. And that tsunami comes in and hits that cliff. It doesn't have the ability to be able to climb like it normally would in a harbor. But the better the harbor, the more that we would want to use it for ships, because it does have this nice slope that ships can come into very easily. That also, tsunamis like to come into that area as well. And so it really gives that tsunami the lift and the gradual climb that it needs to do the most damage and to inundate the farthest. So when you see the harbors themselves, and when the Japanese saw this many, many years ago, and when they named this phenomenon, they recognized that the harbors were the worst affected. Now, I went to the American Samoa tsunami and was very, very clear there afterwards. You know, American Samoa has this wonderful port, a very nice harbor, beautiful harbor. It's actually very well known for that area. But their capital city also right in that particular harbor. And that tsunami actually came into the harbor and not only actually went into the harbor itself, but the harbor gradually turned a corner and went up. And that tsunami, it was very striking that the tsunami actually came into the harbor and turned the corner. And unfortunately, 39 people lost their lives right in that area, and a few other harbor-like areas that are around the different area of that particular island. However, some of the villages in American Samoa at that particular time were next to walls. Hardly any damage whatsoever, didn't reach up into those particular villages. So when we see a harbor, when we know that we're on a fault zone, we have that particular tsunami risk, we have to think in terms of it being more a risk. Now, we also see that phenomenon in Crescent City in California. Crescent City was actually one of the places where there was some damage from the Japanese tsunami in Fukushima in 2010. And the reason being of Crescent City was affected so much, thousands of miles away, was because of the shape of that harbor in Crescent City is very characteristic and very much conducive for a tsunami to come in and propagate after being propagated and then inundate the land itself. Not only do earthquakes cause a tsunami, but there are other causes as well. And actually there are 6 total causes of tsunamis, the most common actually being that underground subduction zone that I talked about that slips, hits the bottom of the water, and then sends the wave out. But there are other causes as well. For example, one of the other causes is you can actually have an avalanche of snow or ice or a glacier, a part of ice that breaks off of a glacier, hits the water, and then causes a tsunami as well. Now, these typically don't cause the kinds of transoceanic tsunamis that we would normally see from the subduction zone. These subduction zones can displace a tremendous amount of land. You know, the Indian Ocean tsunami, there were miles and miles of land that actually did that phenomenon of slapping up against the bottom of the water. Most of the time when we're talking about these avalanches, they're relatively well circumscribed, relatively localized area. But if you're living in that localized area near these areas where this ice falls into the water, makes that splash, it can actually cause some pretty big tsunamis. And actually, even though they don't travel for long distances, they can go very high because of that splash effect. And so some of the highest recorded tsunamis in the world have occurred as a result of this ice. One of them in particular occurred in Alaska. And this thing caused a very high localized tsunami that did result in loss of life because of this particular phenomenon. So now there's a third cause of tsunami as well. It's an underwater volcano. When a volcano erupts underwater, it can actually cause pressure release as well, and the gases and the explosion that occurs from this volcanic eruption underwater then has the same effect as that ground under the water hitting that ocean bottom as well, right? And it causes this outer lying wave once again to propagate as well. So we see this phenomenon as well occurring as a result of these underwater volcanic eruptions. You can also have a submarine or an underwater avalanche as well, where actually a hillside or a slope or some sort of a cliff, and there's rocks that fall under the water themselves. They start off under the water and they fall to a deeper depth, and that displaces water as well. Once again, they're sort of like that ice-generated tsunami. They're relatively localized. They don't tend to spread and become transoceanic, meaning that they don't go clear across the entire ocean, but they can go pretty significant distances, and they can cause a lot of problems with a tsunami disaster. Now, a few generations ago, or one generation ago actually, in Papua New Guinea, an island there that where they had a submarine landslide, and that landslide then displaced, and people only had about 15 minutes in that particular event to be able to see and take shelter and so on after this happened. And you know, the interesting thing about this, I want to share that story with you a little bit more because it really goes to show how a little bit of knowledge can save your life. So in Papua New Guinea, this is a PNG, what people call it for short as well. It's a Pacific island. Not a lot of resources there, not a lot of technology, but this had happened before. And so one of the chiefs in a particular village that was living along the coastline, he saw the water actually recede, and he saw the water actually pull away from the shoreline and go out into the ocean with a long stretch of land that could become, abruptly visible. And he recognized that from his childhood of when that had occurred before, and knew that there was going to be a tsunami coming as associated with that, and got his villagers out into the jungle away from the coastline and actually saved a lot of lives because of that. Once again, just a little bit of knowledge saved a lot of people's lives. That was one of those submarine tsunamis that actually could have been a lot worse than what it started to be, but because of that little bit of knowledge, he was able to make a big difference. Another cause, or a fifth cause of tsunami, is actually an asteroid. And we don't see these very commonly, thank goodness. But from time to time, the Earth has been struck by asteroids. Those asteroids have hit the ocean, and they have created actually relatively large tsunamis. We can expect that kind of power, that kind of impact to really generate transoceanic tsunamis that can be very, very deadly for a large number of people. Luckily, they're extremely rare, but it is one other cause of tsunami as well. And then finally, the sixth cause of tsunami, and we can have a landslide that starts above the ocean, and actually the rocks then fall into the ocean, pretty much like that ice avalanche that I was telling you about as well. That causes the splash. Once again, well-localized area, doesn't travel thousands of miles, but can be very deadly for those people that are living relatively close to that particular phenomenon as it occurs. So I mentioned, this idea of the subduction zone, right, and how that slip of the ground and that displacement can actually cause a tsunami. And there are some indicators that we can learn if we watch for earthquakes out at sea. We can actually judge whether or not, with some degree of certainty, of whether or not a tsunami will occur, because not all earthquakes cause tsunamis. It's actually dependent upon the strength of the earthquake. It's dependent upon how deep the earthquake is underground at the bottom of the ocean. And it's also dependent upon the depth of the water itself. So we have those three factors taken into consideration. And many other national agencies, for example, in the United States, the U.S. Geological Survey, the USGS, they track ground movement. They track the strength of earthquakes. They track possibility of tsunamis, and they use these different factors to be able to measure and be able to predict the likelihood of a tsunami being generated after an earthquake, because like I mentioned, not all earthquakes cause tsunamis. So one of the things that we know that's sort of a general category is that we know that the strength of an earthquake, if an earthquake is greater than a 7.0 magnitude on the Richter scale, it has enough energy to be able to generate a higher possibility of generating a tsunami. Those lower than that, a 5 or a 4 or a 3, much less likely to be able to generate a tsunami. So just by hearing whether it's 7.0 or a 4.0 or 8.0 or a 5.0, I can tell you with a little bit of certainty, a better degree of certainty, whether or not there's a likelihood of an earthquake there. But I need more information. So there's another aspect of this that we know as well that affects these conditions for tsunami formation. One of them is the depth of the earthquake. So let's take a look at the ocean, for example. At the top of the ocean floor, and then the ground underneath the ocean floor, right? That's where the earthquake actually occurs. Now, if it's less than 25 kilometers deep from the ocean floor, then it has a better ability to be able to transmit that movement to the bottom of the ocean floor. Does that make sense? So if it's really super deep, greater than 25 kilometers, 50 or 100 kilometers down, it's much less likely to make that ocean floor move. But less than 25 kilometers from the surface of the ocean floor, that has more of a possibility to translate that lift, to translate that movement into the water itself and generate that tsunami outward. So less than 25 kilometers deep. That's the other aspect. And then the water itself as well. There's not really a specific amount of water, a depth of water, but we know that it's more likely in deeper water because, of course, there's more water there to be displaced. So if you hear of an earthquake that's greater than a 7.0, that is less than 25 kilometers deep, you need to be thinking about the risk of tsunami being generated in that particular example. Now, how can we tell about this stuff? Well, actually, one of the great things about smartphones is the warning systems that these smartphones are able to provide to us. We can receive earthquake warnings, we can receive tsunami warnings through our phones. And actually, I have a system that's set up through U.S. Geological Survey. It's a free service that's provided by the U.S. government that tracks earthquakes around the world and can actually tell you, sends a message to your phone when an earthquake occurs in that area of the world that you want to know about. You go to the USGS survey website, you sign up for that, and it'll tell you can choose it in the Pacific, you can choose it in the Mediterranean, whatever, and you set the parameters of what you think would be the earthquakes that you want to hear about. Now, I want to warn you, if you set it for a 2 or a 3 magnitude, you're going to hear about a lot of earthquakes. Your phone's going to be going off, going crazy. But if you set it for a parameter, for example, like we're talking about a 6 where it's movement that's relatively significant, or a 7 that can generate a tsunami, you can get warnings. And also, in addition to the warning of the earthquake, the USGS also provides a tsunami alert as well. So they actually tell you if there's possibility of a tsunami or not, using these types of parameters. Now, what I've shared with you is basically just some rough guidelines. 7.0, less than 25 kilometers. There, of course, these are exact scientists. They're a little bit more precise in this as well. I want to give you that sort of general guideline, but I also encourage you to get a little bit better information when you're talking about this warning system. If you live in a tsunami area that could be affected by tsunamis, I want you to be able to have that early warning. I encourage you to be able to go to that site and sign up for those. So there are typical characteristics of tsunamis that we can use to be able to protect ourselves. Number one is that 90% or 95% of the cases of tsunamis occur in the Pacific Ocean. It's because of that ring of fire that I told you about. The Pacific plate is very active along its periphery. There's a lot of earthquake activity there compared to other areas of the world, and therefore the overwhelming majority of the Earth's historic tsunamis have occurred in the Pacific Ocean. So if you live along the Pacific Basin, live along those Pacific Rim countries in a coastline area, we should be thinking in terms of protecting a tsunami, protecting your family and your community from tsunamis. Also, tsunamis travel fast. They travel 300 to 600 miles per hour, and so it's the speed of a jet plane. So traveling that quickly, we know that they don't lose much power over that long distance, and they travel quickly. So we know just about how long it will take a tsunami to get from one area to the other, and we can predict that as well. In addition, most tsunamis, the majority, are about 10 to 50 feet high. However, there are some tsunamis, for example, the one in Indonesia, the Indian Ocean tsunami in 2004, that actually went up to 80 feet tall, higher than the palm trees. And so in that particular example, tsunamis were higher. I'm only giving you sort of a range of 10 to 50 feet, but we do know that that can actually be, of course, smaller or a little bit larger. And we have to recognize as well, this tsunami risk in the Pacific is because of that Pacific plate. So the Pacific plate sets in the center, and then surrounding the Pacific plate, of course, North America, South America, Asia, Australia, and then of course in the middle, these Pacific islands. So all these coastlines are affected by the tsunami risk. 90% of the world's tsunami risk lies in what is called the ring of fire in this area. They call it the ring of fire because that subduction zone, the periphery there, creates earthquakes, but it also creates volcanoes. So we have a big area in the Pacific that we have to be concerned about.